Why is it so hot these past few days?
Probably the climate change during this globalization, I suppose.
Let me explain the real reason why the weather is so hot the past few days. The changes in weather is due to the presence of the ultraviolet ray.
UV radiation is present in sunlight, constituting about 10% of the total light output of the sun.
The reaction of alkane and halogen under the presence of UV light and heat, they will lead the formation of haloalkane. A good example is chlorination of methane. Now I'm going to explain about the radical chain reaction. The reaction is characterized into 3 steps. The first one initiation, second one propagation, and the third one termination. The first one requires energy input, but after that, the reaction is self-sustaining. The first propagation uses one of the product from the initiation process, but the second propagation will make another new one. Thus, the cycle continues.
The bond that is ruptured is said to have broken in a homolytic fashion, that is, each of the originally bonded atoms receives one electron. This initial reaction is called the initiation step of the mechanism. The chlorine-free radicals that form in a high-energy state are ready quickly to complete their octets and liberate energy. Once the high-energy chlorine-free radicals are formed, the energy source, UV light or heat, can be removed. The energy liberated in the reaction of the free radicals with other atoms is sufficient to keep the reaction running.
When a chlorine-free radical approaches a methane molecule, a homolytic fission of a carbon-hydrogen bond occurs. The chlorine-free radical combines with the liberated hydrogen-free radical to form hydrogen chloride and a methyl-free radical. This is called a propagation step, a step in which both of a product and a reactive species, which keep the reaction going, are formed. A second propagation step is possible. In this step, a methyl-free radical reacts with a chlorine molecule to form chloromethane and a fluorine-free radical.
When a reaction occurs between free radicals, a product forms but no free radicals are formed. This type of reaction is called a termination step because it tends to end the reaction. There are several termination steps in the chlorination of methane. A methyl-free radical reacts with a chlorine-free radical to form chloromethane. 2 methyl-free radicals react to form ethane. 2 chlorine-free radicals react to form a chlorine molecule.
Hi guys, today let's talk about alkanes. Alkanes are generally stable and relatively inert molecule. When an alkane and halogen mixes and it is exposed to UV light, substitution reaction occurs forming haloalkanes. UV light causes some of the bonds to break in the halogen molecules, creating what we call a very reactive halogen atoms, also known as free radicals. These free radicals are strong enough to break the bonds between the CH and room temperature. This type of reaction is also known as a radical chain reaction.
One problem though, the chlorination of methane does not necessarily stop with one chlorination process. After the chlorination process has occurred in the first place, it can occur over and over again until it is very difficult for monosubstituted chloromethane to be obtained. In order to avoid this problem, we use the high concentration of methane in comparison to chloride. This reduces the probability of a chlorine radical to run into a chloromethane, causing the process to start all over again.
it will form dichloromethane instead of the chloromethane. This method of controlling ratios will enable a person